on that correction. Let's move on. Just finding here. Next topic is to be able not to look only at one proportion, but to look at two proportions and compare them with each other. Like, are there any difference, say, in genders? Do females more often prefer Obama than males, for instance? Just to take one set of two proportions you would want to look at. Another set of two proportions is the example 2 I brought. Is kind of those study within the medical science, investigating whether there are any difference between maybe treatment groups, or in this case, whether a certain female population group were using birth control pills, pillar, or not. So that is the definition of the two, you could say, populations, or the two groups you would be interested in comparing. And what you, in this case, would be interested in comparing was how many of those were actually getting a certain disease, in this case, a blood clot, hjerteinfarkt. So out of 57 females using birth control pills, of this, we don't know exactly who the population are otherwise, but it's a given population from a hospital. Out of 57 sampled, 23 from the birth control, you could say that is the P1 hat. That is 23 over 57. What's the percentage there? I think I brought it. Here we are. Here we are. Around 40%. And what about those females not using birth control pills? I had a bit more of those ones in the sample. I had 167 actually. 167, that was the N for this group. What is the P2 hat then? That would be that I had 35 getting the problem out of 167, with the percentage being only around 21%. So among the birth control females, 40% got the disease. Among the non-birth control group, only 21%. The question is, are these, of course they're different. I mean, there seems to be a higher risk in the birth control group than in the other. But is it a risk? Is it statistically significant, right? Is it really proving something? Or I don't have that huge amount of data for this conclusion. I only have 57 female in one group and 167 females in the other group. Is it strong enough to make any conclusions based on that? That is the hypothesis test that we should do here, right? We should do the hypothesis test of the two proportions being the same versus, in this case, I would say the alternative of them being different. Could be one-sided alternatives also here, but let's work with the default, the two-sided. Now I'm going to do this part really short and rapid. I'm just going to show you this slide basically until we move on. It could be done. This is one of those hypothesis tests. I don't know, maybe the only one, but don't take me on the word here. But at least it's an example of where I'm going to present to you two different ways of doing the hypothesis test. More specifically, two different ways of computing a test statistic. First, I'm going to give you a test statistic, which is a direct generalization of the one we just tried on the single sample one, where I simply compare the two P's directly with each other and divide by some binomial uncertainty as before. And then I do hypothesis testing as usual. If the set is too weird, too large, I reject. If not, I accept, right? There is a P in here in the formula. The P, this is this kind of joint P, the joint risk, where I take all the deceased and divide by the total amount of people. Now, this would be one way of doing it based on the standard normal. And I could do it here, but I will not. That is as far as this is a tool that only works for two proportions. So we'll stop here and move on already to the next,